Well, hey, thank you all for coming out today. Thanks for spending some time. We've got about an hour scheduled, maybe a little less than that. We won't keep you longer, but the plan here is we're going to talk a little bit about some DevSecOps related trends, challenges, and solutions. We're a company, so we might show off a couple ways to solve those things. And at any point, feel free to drop questions in the chat, or you can DM us, and we'll answer those at the end, unless something comes up throughout that fits into kind of the narrative without disrupting my flow too much. We'll see. But these things are always best when interactive. So I do encourage folks to share feedback or questions in real time. So we're going to get started. We're going to talk about a couple things today. So we're going to talk about shift left. I know. I'm not going to say the next one. Just you can probably guess what it is. And then we're going to talk about runtime and what that means in the context of application security, and some different ways that runtime knowledge and context can be applied to solve traditional application security challenges. We'll talk a little bit about our product, because hey, it's kind of what we do. And then, of course, leave some time for questions and answers. But before we get started, just by way of introduction. So I'm Josh Thorngren. Once upon a time, I was a development operations manager, because I'm old enough that we hadn't put those words together yet and shortened them. I've spent the last decade or so helping scale up marketing and product organizations for application security and DevSecOps companies. I'm currently doing both at For All Secure. With me is Vincent. Vincent runs customer engineering here, customer solutions. Well, welcome, Vincent. Sorry, I'm doing your introduction for you. I know.
Okay.
It's
so good.
Yeah. He's an avid trail runner. He makes me exercise when we go to conferences, which is always great. And a ex-engineer and DevSecOps lifer. Who are we like as a company? Well, we both work at For All Secure, and For All Secure's GodStar is a hacking organization of folks who lent out their skills as white hat attackers for hire. And over time, develop some technologies that could be used to really improve application security for teams who are building and shipping software. And so we make Mayhem. It's a platform that uses a bunch of techniques that attackers typically use to find reachable and exploitable vulnerabilities in your apps and APIs. That's us in a nutshell. So, with some of that housekeeping out of the way, why don't we go ahead and get started? So, okay, shift left. This whole notion was, let's take the security scan that happens after you deploy software. Let's take the remediation efforts that happen after you deploy software, and let's, shift those things to the left. Let's turn it into this. Let's scan and remediate at different phases throughout the development pipeline. Now, your organization may have 5 different ways to slice and dice across your pipeline. I'm just showing this at a 50,000 foot view. Why did we do this? Why is this something that even today in 2024, us and other application security vendors are still talking about? Well, at the end of the day, it comes down to the thing it always comes down to, which is money. Remediation is expensive in production. When you think about the context switching, the slowing down of velocity, the effort to update systems, all the testing to make sure patches work, it's just an overwhelming burden. IBM did this study in 2020, 2021, and what they found in surveying organizations across the globe was, when you're remediating a single security issue pre-production, it's about $80 of cost to the organization, compared to nearly $8,000 when you're doing that in production. That's for a single issue. So, okay, there's a real imperative to try to fix things earlier on in the pipeline. And out of the same part from IBM, what they saw was, if you think about, hey, we're just designing, we haven't even started to add code in, all the way through to production, the scale up comes early on and gets more significant once you cross that final production hurdle. So look, obviously it's better to fix things locally than it is to fix things in test environment. It's better to fix things in test environment than it is in production environment. What you really want to do though is make sure that locally test, you're fixing as much as possible as early as possible. So why? Like, hey, it's great that we're saving money, but from an actual like security perspective, development perspective, like, cool, but how do you actually recognize that in your organization? Well, you improve speed and security, and this is always the DevSecOps promise. It's look, you can have safer software just as fast now that you've shifted left, or you can have faster releases that are equally as safe. The goal, of course, is you bring those together so that over time, you're getting both safer and faster by integrating security across the dev lifecycle. I think most folks on this call, you're probably familiar with these concepts to some degree or been exposed to them before. This isn't groundbreaking. This isn't anything new. So anyway, that shift left. Hey, guess what? We did it. Now there are no more vulnerabilities. Everything got fixed. We're done. Thank you. Great. Yay. And we all lived happily ever after, and there haven't been any attacks, right? 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 It's not really the case. Like, shift left brought with it a whole slew of other problems, because what we did was we took techniques that security teams use to scan production infrastructure, and we said, let's go apply these techniques to code repos. Let's go apply these techniques to source code. Let's go apply these tests that a pen tester used to do and run them against a build artifact. And this is the problem that shift left created. And if you've already integrated security scanning into your pipelines, you feel this pain acutely. It's been years since I've talked to a customer who has shifted left who doesn't have the problem of noise. And the joke I always make when I share this statistic is, as you might say from those IBM quotes earlier, I'm a big believer in taking numbers from other people's studies. This one I think is from the folks over at Fastly. This is the best result that I can find across all AppSec vendors everywhere in the world on, hey, how many results in AppSec are real? And look, everyone's motivated to say there's a lot of noise, everyone else's results are bad, not enough of them are good results. But if this is the best, it really says a lot for how the industry has evolved ever since we shifted left. Sure, we're fixing more things early on, but we haven't really evolved the how we're finding what needs to be fixed. And as a result, teams are burdened with noise. This is exacerbated when you think about how much folks use open source software, all the different dependencies, third-party packages, and the complexities of your supply chain. As we've gotten better at shipping software, as we've gotten this move to microservices, distributed systems, as open source has been on the rise, it's no wonder that you have so many false positives. And this is a Pokemon Institute. I always want to say Pokemon. I apologize to them. If anyone from your fine institutions on the call, I really do apologize. But it's over $1 million a year is the cost to a company dealing with false positives in their AppSec programs. That's a lot of money. I mean, it'd be nice to say no big deal, but it's a lot. So we shifted left to lower the cost of organization of doing security. And at the same time, we've imposed this massive cost on the organization for doing security. It seems like we're not necessarily achieving our goals. And you think about it, well, organizations view false positives as worse than missed vulnerabilities. And I think it's interesting. 2/3 of folks, they say, look, I'd rather have fewer false positives and more true positives. And look, it makes sense, because if you don't know what is real and what's not, it's really hard to prioritize what to fix. So, okay, you gotta sort through everything. But here's the problem. about that same percent of organizations say that it takes longer to triage a false positive than to remediate an actual vulnerability. So let's think about that for a second. Going from end to end, updating a dependency, patching some code, testing, deploying, that's faster than doing the work to figure out if something actually matters. So if about half the results are bad, and it takes significantly longer to figure out what's bad and what's not than it does to fix things, all of a sudden that million plus number doesn't look that weird anymore, because we're burning our cycles on remediation. No, we're burning our cycles on triage. We're burning our cycles on following up on alerts, not on actually improving security.
I wonder if that's also because triaging a false positive is like a pain in the neck to do. It's administration, it's annoying work. Or fixing a
Well,
vulnerability, that's just development work. So
you get to code. You get to code. I mean, I
exactly.
think I think you're spot on, Vincent. I I mean, I know even within our own work, like it's not that one person can triage something.
Right.
Someone does an investigation, but it's IT work, and then but how is this deployed here in this environment? What are our settings? And
Also,
it's
someone has to probably sign off on it. Like if I have a developer think, hey, well, this is a false positive, I probably have to give it to someone that and actually says, okay, well, I've validated that and it is indeed a false positive, versus just fixing it. Like I don't need like a chain of control
yeah,
there.
yeah. Well, it's I think it's really interesting when we talk to customers, and what they care about is, hey, how do I manage my risk register? How do I manage my justifications? Because when security doesn't know what the real risks are, every argument, every conversation, every result is an argument. It's dev saying, well, let me tell you about this one, and security saying, but it's still a result. You got to give me something. And then you're going back and forth on the minutia there. And it doesn't set anyone up for success. So like really what you need is you need the lowest number of false positives so you can fix more real issues, and the highest number of real results so you have more real issues to fix. Like, great. This is not ideal, glory state. Um, so in Vincent, kind of following up on what you were saying, I think part of it is like, well, how do we even think about what a false positive is? Like, triaging is kind of a mess. Is the report accurate? I worked for a company maybe about 6 years back, and our thing was a false positive was a bug. So, file a bug ticket. We'll treat that like a bug. And like at the end of the day, that sometimes you just get a report that says, well, you're using log4j and it's nowhere in your code. Well, that seems pretty wrong. What's going on there? Or it says you're on a version that you're not running anymore. Okay. So now you've come through your code. Hey, guess what? You've done a search in your repo. Great. Step one. I can do that. But then you use the dependency. There's this is a fun example of a 9.8 CD in zlib. Well, I think it's like Debian-based Redis image has it. Well, hang on a second. That's actually an app. It's in the package manager that just comes with the image. So you're not using that. You're not actually vulnerable if you run that Redis image. But Vincent, to your point, like, does the developer who gets the report know this? Or are you going and reaching out to the architect? Are you pulling apart the container image? Are you understanding how this is actually used in production? Hey, how does the customer deploy this? Like, it starts getting more complicated. And then there's the fun justifications, which is the sure. I do use that package, but we never actually invoke that function, so we're safe, it's fine. And great. Like, I find the person who wrote the code. Like, that's how you can get the knowledge. But now we're starting to talk multiple steps away from the security team and from a developer who's tasked to do a remediation. And this is all just still in triage. So you're trying to get further and further away. And then of course there's the other piece, like, sometimes this is the end, sometimes this is earlier on. Like, does it even matter? Like, if you can only exploit something over a network and you're running a single node in an air-gapped environment, do you care? Sure, it might be high severity, but do you care? Vincent, to your point, like that's not a developer making that decision. That's security, that's GRC. It's, do we have to close this out because it's required for an audit? Do we have to close this out because it improves our security posture? Do we have to close this out because insert one of a dozen reasons here? Sometimes the answer is yes, but what's the risk? And if you could communicate whether or not that was actually a risk earlier on, would you have to do all those things and how? And so, yeah, this is a messy process. And you can see it's messy because the slide, the things go up and down too, which is how we all know it's messy. So, just thanks to our marketing team. So like, okay, look, let's just kind of book those things. So it's like bugs in your scans. It's packages, dependencies you don't use. It's specific pieces of code or functions you don't use. And it's stuff where there's a mitigation that you feel like you can talk about. Okay, great. So that's about half of all the results you get. That's just triaging. So you gotta go figure out all those things. So Vincent, this goes back to your point. It's like, well, what's the process? You can file a bug ticket with your vendor. You can write a justification. You can remove unused code. You can do some testing after you remove unused code. You can, write a justification. You can, wait, you can write justification. Really, the process is you have to fix things or you write a bunch of justifications. You write the justifications based on your or your teammates' knowledge of what's actually running. And so it's interesting because there's a theme here of knowing how your application actually runs. And it's not, hey, Vincent built the app, so Josh just goes and asks him. It's not, well, Josh built the API, Vincent built the front end, so we just go to them. It's how do you make that information something that your entire team is aware of? So this starts to be onto something here. Because if this is happening manually with every single type of false positive before you can triage it, as you're handling it, how do we start to take this data about what's happening in runtime and use it automatically to improve this process and eliminate some of the bugs? Like, look, at its core, it's pretty simple. It's, focusing on the noise you get from your dependency focused tools, your SCAs, your SBOMs. That's a static list of every CVE that may or may not ever get used. Every CVE and every dependency. Great. Spend the time triaging, do all that. It's starting to slow down. But if you can combine that with observability, if you can combine that with something that's understanding and profiling what your application does when it runs, you get a dynamically built SCA report or a dynamically built SBOM that shows what's actually reachable on your attack surface and helps you filter out, these are the issues I know are real that I need to fix. These are the issues that I haven't verified yet. They might not be real. And so all of a sudden you start getting that number of real results higher. Now, you get to deprioritize false positives too, because you're not seeing it. So maybe it bumps down to the bottom of the queue. So like the runtime context really helps eliminate that. Like, imagine these are all the severity colors of the findings. And hey, guess what? Some of them, hey, they're not really risks. It doesn't matter. Look, they're green, it's great. But if this is your static SCA report, what if you start to apply runtime context? What if it looked like that instead? Because the only things that you saw or you were told to remediate were actually proven to be used at runtime. That's the dream. Like, that's how you need to match up the observability data. So, okay. I mean, we all monitor production instances, right? Like, you just have to. You got to deliver a good customer experience. So, okay, let's take that knowledge, match it up, and yeah, great. So anyway, again, thanks for coming to the webinar. We solve security forever and have fun. Just match it all up. It's great. You should never trust it when you see the, auto dealership, balloon guy floating around, because here's the problem with thinking about runtime in the context of security. Okay, so we shifted left, we shifted this scan remediation left. And then we deploy it, and then we see what's happening after we've deployed our software. And then based on what happens after we deploy our software, we go and start fixing things. And ooh, Vince, I see you're thinking about this. I mean, I'm thinking about this. I mean, I made these slides, I'm still thinking about this. Like, developers, by the time you're building a production profile, we're shipping new code. Let's go build something new. I don't care about what we shipped. Where's the newest feature? Where's the newest improvement? Let's get to the next version. Maybe you fix 5 things that were old dependencies in production anyway. And then, okay, even if it wasn't for that, so we're back to the $8,000 a pop remediations in production. This doesn't really feel like we're solving problems. This feels like we're creating some problems that we already solved in order to solve new problems. And great. So what, we have a second coming of shift left in another 10 years? Like that doesn't work. So this is where we have to be thoughtful about how we think about what runtime is, but also we need to be thoughtful about what problem we're actually trying to solve. So earlier we said, look, it's about the highest number of real results, lowest number of false positives. I'm going to propose a new equation. You need the earliest detection of the highest number of real results with the lowest number of false positives. And let's break this down, because it's not just about eliminating the noise from a scan at a point in time. The whole rationale behind DevSecOps is you make the cost of individual fixes cheaper so that you can fix more things, so that you can faster, safer, ideally both at once. So the things that you need to really prioritize being shifted left are, how do you figure out the largest number of issues to remediate with the minimum amount of noise for triage? The earliest detection gives you the lowest per fixed cost. The highest number of real results gives you the biggest bang for your buck as far as security improvements. The lowest number of false positives means that you aren't wasting your time triaging. You're actually able to execute against your list of vulnerable packages, CVEs, CWEs, etc. So we've got to find a way to start building out a profile of real results as early as possible. And that's a little bit different than eliminating false positives from your scan. This is, how do you show the things that are known true positives as early as possible and deprioritize the potential false positives until all the known ones are remediated. That starts to be a model where you're moving the needle on both velocity and security. So, I mean, let's think about that for a second. I just said, all of these are real issues. All of these are real issues. Then we can layer in, well, you've got some other CVs. Haven't seen those yet. Not sure if they're real. But guess what? Because you're focused on, let me build a profile of what's known first, you're able to start remediation earlier without spending time early on triage. That starts to get you the benefits of both the shift left and the runtime context. So you have to build your profiles in your pipeline. if you rely on production data, yeah, you're solving some problems, but you're also returning to a world where you're doing remediation based on what's live, and you're always in a game of costly catch up. That's the way you can have both. So this is going to surprise everyone, I know. Mayhem. Remember that product I
What?
mentioned earlier? Yeah, I know. Vincent, can you believe it? It's
I didn't know this. I wasn't prepared.
I
Dang it.
hey, it's okay. Well, if you can just like maybe show everyone like, I don't know, Gmail or something. I guess that'd be great. But hey, I'm gonna turn it over to Vincent because guess what? He's gonna show you how some of this can work in a pipeline.
Yeah, let's do it. Let me steal your screen share. And all right, I'm gonna show you a couple of things. I'm gonna show you fun terminal interactions because everybody loves black screens and green letters. That's But I'm going to show you UIs as well. I'm going to show you pipelines. I'm actually starting with the pipeline here. So showing you GitHub Actions, just as an arbitrary example, a CI/CD pipeline, where we're actually building a Docker container here. And in this case, we're just using as an example of Postgres. So we're have a container of Postgres that we start up, or in this case, start it up, make a connection to it. That's really everything that's going on. But because we have Mayhem plugged into the container runtime, we've now built up a micro profile of what that individual container does, the specific version of that image. So that's great. So we have information from early on in the pipeline, how your application is behaving. If we then use that directly in the pipeline, remember, in this situation, this could be a container that has been freshly built, completely new. So there's little other information about that, about this specific version, mind you. What we can do then is run Mayhem, and in this case, the utility MD SBOM, the dynamic SBOM, that actually will invoke a third-party SBOM and SCA provider. So we're not reinventing the wheel. There's tons of vendors out there that are already creating that. A lot of open source examples, such as Docker Scout, which is the example that I have right now. So really what's being done here is under the hood, Docker Scout is being ran on that image. I could do it myself as well and then pass the SBOM report and the SCA report to the dynamic SBOM. That's possible as well. Right now it's packaged all in one. And what will happen is it will check the profile that has been created for that application, for that version. And it will take a look at, okay, what are the elements in the SBOM report that were actually observed at runtime? So let's take a look at something a little bit more visual. So a Serif report, which is used a lot in these contexts, is something that can be read by GitHub's advanced security, which is what we're looking at right now. Of course, every CI/CD solution has an equivalent of that. And of course, what we can see here is what is open and what is closed. And what we see is that there's, 49 open, 45 closed. Well, that's interesting. Why is it that there's already 45 closed? I just scanned this container. In this theoretical example, it could be a completely new container. Of course, this is because the profiling of the application that was just done, again, in this example, in the CI/CD pipeline, but as Josh mentioned, that can be information that's sourced all the way from the right, so from production profiles as well. So in this situation, what we can then see, hey, these packages, technically Docker Scout, like it's listed here, so that's the original source of the vulnerability, did find a component in there. But if we scroll down, in this case, how the pipeline is configured is if there is a suppression in the Serif report, which is what dynamic SBOM adds, the issue automatically gets closed. And of course, you can add it in different states depending on what you want to do with it exactly. But so there's a very clear distinction between what are the vulnerabilities that are actually open and what are the vulnerabilities that were not observed at runtime. So what can I do now? So first of all, everything that's closed, initially I can ignore that because I know it's not being used at runtime. But there's a second advantage to it as well. Because I know it's not being used at runtime, that could inspire me to just remove those dependencies because they're not being used at runtime. A lot of individuals that run this would start using, for example, different base images because a lot of these vulnerabilities are actually not of your application. They're just in the base image. Why are you running on a rel base image? You could be on a distro-less image as well. So these are some of the insights that you can get. Josh.
Vincent, I love what you're saying about removing stuff. You know what someone should do? Someone should build something that could like, open up a PR that says, hey, we noticed this wasn't used. We can remove it. It like kind of like Dependabot, if you're familiar with that,
Right. Totally.
maybe.
Yeah.
And they should call it Removabot and not let anyone talk them out of calling it that.
Yeah, exactly.
That'd be great. That'd be great. That's all. That's all I'm gonna say. Cough, cough,
Yeah.
roadmap.
Join us
We're
for
not
our
actually. We're not
webinar
calling it
next
that.
week for our new product, Removabot.
Yeah, we won't call it that, but coming this summer.
Exactly. The secondary thing, obviously, here is everything that's open. You now know that it's actually open and you need to do something with that. So you can use that as a great indicator of priority and jump right in, look at all these different CVEs and start resolving them. Of course, all the details that are listed here come from Docker Scout. So generally, this is very helpful for a developer to see what's going on so they can upgrade dependencies, et cetera, because that's usually what's called for in these situations. So it's, of course, great. And I think most powerful to see it as part of a CI/CD pipeline because this is what developers are looking at every day. This would integrate into their pull requests as well, because right now I'm just showing it for the main branch. But the moment that I'm a developer, I'm working on a pull request, I'm adding some dependencies for the feature that I'm working on. I would get this exact same report on my pull request. And guess what? Because my container is being started in a CI/CD pipeline, there is a profile that can be combined with production data as well. So we already know what kind of things my container does. So even before I merge code into main, so it hasn't even made it into the product yet. At that point, I can already see, okay, this is something that I can immediately remove, or it's something that's not on the attack surface. Sometimes if you add something that pulls in an additional dependency that you're not aware of, that you're not using. So in this case, you would immediately see that versus in other situations where you have to wait for, being much further in the pipeline where you then actually find out, hey, there's actually an additional tricky dependency that was added I didn't know about. And that now creates problems in getting my application certified. But of course, there's different ways to visualize it as well. I promised a terminal. So anything that we're doing in the CI/CD pipeline, we can, of course, also do on a terminal. So in this situation, I'm showing you actually a runner, the GitHub runner that runs that pipeline. So on that runner, we have that profile that is being built up every time that I run that application, which is synchronized with the Mayhem platform so that I can combine it with different environments. So in this case, what I can do and what I just did is run that same report on the command line. So even if I just build a new container, I can start that container. I can just have it up for a second, and I can close it, and I actually immediately can run that report. So even if I'm doing something with a very, very short feedback loop, and I don't really want to wait to push it, et cetera, I can run it on a local environment as well. All that I need to do is install this so that it's plugged into the container runtime and log it in so it synchronizes its profile information. So you're not necessarily limited to using it in a pipeline. You can just run it locally as well if you would want to. Of course, this rolls up to the Mayhem platform itself as well. So we have functionality here that showcases, hey, this is the information that we've collected by combining these different reports from all the different environments. So here we see in a nice visual way, sort of the equivalent of what we saw in GitHub Actions, the same that we saw on the terminal, but now part of the platform. So you can imagine that here, this is a good moment to add a little bit more granularity, right? So for example, I can work on justifications here. I can track it. I can link it to Jira, all these like integrations into my workflow. I could do that from the platform. I can do it from GitHub Actions as well. So because we're living in a great cybersecurity world where all these SBOM and SCA reports are very open, you can integrate it in any way you want. But this is a nice way to get that overview. So I can see, of course, my defects, very similar to what we saw in GitHub Actions, with all the details that help me to resolve some of these things. And I can also just focus on the SBOM aspect of it, where I can focus on and ask, hey, I just want to show the packages that actually have been observed in runtime. And what I can see right here, which are the dependencies that I have that are actually causing some kind of problem, that have defects, and which are the ones that are completely fine. And this can, of course, be very helpful for me to see, okay, what do I need to do to get rid of some of these CVEs? It can be, for a developer, sometimes easier to just look at the packages before they look at the CVEs, because I don't really need to understand the individual defects if I see that there's a package which has multiple problems, and I can just upgrade it to a newer version where these problems don't exist. So that's the really short overview of how we combine this profile running on different environments, how we can see it in a CI/CD pipeline, how we can see it on the terminal to have a really short feedback loop as I'm actively developing a container, maybe removing dependencies, running it again, seeing what the effect is, and as well as how it's synchronized into Mayhem itself so that I can more integrate it in my workflow. Cool. Back to you, Josh.
Awesome. Thanks, Vincent. And I see we're starting to get some questions coming in. Let me just, hey, I'm gonna skip the part where I throw up the nice little thank you slide that says any questions. John, to your question around, hey, how are we determining what packages are used or not at runtime? There are two pieces to what Mayhem's doing. So there's a piece where it's building a profile of what's happening as your application runs. I'm gonna give you the, let's call it the 20,000 foot view without going into minute technical details. Essentially, we take permissions similar to what a container runtime does and use that level of access to a system or a node to log the behaviors of an application. We do this asynchronously. And so we're able to pass that information back to Mayhem and build that profile up. There's a variety of different system level tooling in place there that generates the profile across all your different activity vectors. It's nothing in line, it's nothing instrumented. It's asynchronous and it deploys alongside. You can think about it, everyone wants to say things like agentless or like it's a service, it's an agent. Think about it like that runs alongside. Yep.
Give you a visual,
Yeah.
Might be helpful.
Look at that. The second piece then is how do we ingest data about how those things match up and do that? So it's, okay, this file was observed. This file corresponds to third-party dependency X. This process was observed. This corresponds to third-party dependency Y. We're looking at that level and doing the matching. In most cases, we're inferring the data of that via a combination of our own tech and if we're ingesting a third-party SBOM or SCA report, the information provided there. Let me know if that answers the question. We can follow up. Just because of the timing here, I'm not going to do a deep, hey, let's dive into architecture, let's go look at it, but we can also schedule time for that as well. Celis, to your question around behavior of the application, like, and Patrick, I see your question about like, how do we ensure we don't miss things too? I'm gonna kind of talk about these both at once. There's a really big notion with runtime observability that you want to get as granular as possible and as fine-grained detail on what's going on in your environment. Doing that usually comes with trade-offs, be it instrumentation of your code, be it kernel mods, be it some level of inline telemetry or recording. It's not that those approaches are in and of themselves bad. It's a trade-off that you get to have additional granularity. To the question around, hey, how does this actually, like, how do you make sure you don't miss things? We're not trying to give you an exhaustive profile of every single what if and maybe and under these exact conditions, actually this one line of code that never, ever would be invoked otherwise runs. There are always going to be more vulnerabilities to remediate than you have time for. And if that world changes, I honestly, then I'll put up one of those, floaty guy doing that slides and actually mean it. The goal is, how do we start to slice down and deliver results that are real as fast as possible? So with that as a concept, the way that we architect Mayhem and specifically the profiling service is with individual layers of granularity. So how do we start by looking broad strokes? Okay, let's look at file behavior and match it to dependencies. Then how do we get tighter and tighter? Let's look at network calls. Let's look at processes. Let's look at individual actions and match those up to dependencies or within dependencies. You can go get more granular. You can go all the way down to eBPF style logging. All of those are opt-in. And we're going to continue to add pieces to Mayhem that gives you more and more granular. Right now, our focus is really on those top levels, because what you're able to do is you're able to slice down your results very quickly and prioritize things that have to be fixed. If we can do that, we're able to better solve the problem of too much noise. If we go more granular just from the onset, you end up having to, you're in a battle of like, and Patrick, to your question, you're in a battle of like, how do I build an exhaustive profile before I do anything with it? Or how do I find like the hidden vulnerabilities? Look, there's a whole other part of Mayhem that we're not talking about today that does stuff like that. That's not really, what we're doing here. When we talk about behavior of application, we're looking at different levels of what's happening on the system, from files to processes, network calls, so on and so forth. Anything that starts to impact performance or require you to make security level modifications beyond just the, hey, it kind of looks like a container runtime, is opt-in. You get more granularity. In our testing, there's diminishing returns the more granular you get on noise reduction versus amount of things you actually remediate. Tell us, Patrick, hope that answers kind of both questions at once. Happy to elaborate further if needed. All right. Well, with that said, if there are no other questions coming in, then, I'll close it out with a little, hey, thank you slide. Here we go. Feel free to reach out to us on mayhem.security. You can email me, email Vincent, Josh at forallsecure, Vincent at forallsecure, or hit us up on LinkedIn or your platform of choice. And, it's going to be at RSA next week. Come say hi. We'll give you some free swag. All right. Hey.
Awesome. See you at RSA.
Thanks, everyone.